Hello, my name is Jacques, and today we're going to continue learning the basics of the Bevy Game Engine. Bevy is a simple data-driven game engine built in Rust. It's free and open source. This tutorial is the second episode in my Learn Bevy 0.10 video series. This episode builds on what we learned in the previous episode. With Rust installed, open your terminal and cd to a directory of your choosing, and make a new project with the cargo new command. I'm calling this new project Bevy-ball-game. Open your newly created Rust project with an editor of your choice. I'll be using VS Code. You should see the following files have been created for you. A source directory with the main.rs file, a .getignore, a cargo.toml file, just like we had before in the previous episode. Note, if you're using VS Code, I highly recommend you install the extensions we looked at in the previous episode. Open your cargo.toml file. Add bevy.0.10.0 under dependencies so that your cargo.toml file looks like mine. Now, in your terminal, build your project with the cargo build command. Again, this will download our dependencies and compile our project to the target directory. Once your project has finished compiling, we're going to be creating some folders in our project directory to place some assets we want to use. Within your project's root directory, create an assets folder. And within the assets folder, create an audio folder and a sprites folder. Your project structure should now look like mine. We're going to be using assets from the Kenney.nl website today for our project. Kenney provides amazing assets free to use with a public domain license. If you use their assets often, I highly recommend becoming a Patreon or donating. We're going to be using the following assets: the rolling ball assets, the impact sounds assets, the sci-fi sounds, and the interface sounds. From the unzipped downloads, please copy the following files into your assets and sprite folders. Copy and paste the PNG files into your sprites folder and the .ogg audio files into your audio folder. You should now see them listed in VS Code. Let's get started on coding our game. Open up your main.rs file. Add the use Bevy prelude to the top of your file to import our Bevy dependency. In our main function, let's start by creating a new Bevy app and immediately adding the add default plugins. This will allow us to get rendering, Windows, UI, audio, and other functionality from Bevy that we're going to need to make a game. Running our application now with cargo run, we see we have a blank Bevy project and a window that opens. Hit Ctrl-C in your terminal to close it. Let's get started on our first component and systems to spawn in our player. Let's start by creating a player struct and deriving from the component macros we saw before. This tells Bevy that the player struct is now a component. Let's create a Rust function called spawnPlayer. As part of the parameters to our function, we're going to need commands to spawn in an entity with our player component. We're going to need a query to our window to get information on the width and height. Make sure to import the primary window at the top of your file. And lastly, we're going to need access to the asset server through a resource in order to load in our PNG file. Bevy creates an entity with the window and primary window component for us, as well as a resource holding the asset server. It's just up to us to use them. In the body of our function, we start by getting a reference to our window through our window query. We use a new method here called getSingle, which we haven't seen before. Instead of iterating through a list of components using the .iter method as we did in the previous episode, here we know that only one entity will exist with both a window component and primary window component, because these are created by Bevy. Lastly, getSingle returns the result type, which could be either the thing we want or an error if it doesn't exist. We know that in this case we will have a window, so we can simply use the .unwrap method on the result type to give us the reference to the window. Next, we're going to spawn in a player entity and add the player component to them. We're also going to add a new component we haven't seen before called a sprite bundle. Here in our spawn function, since we were going to add more than one component, we're going to wrap them in a tuple. Inside our tuple here, we'll start with our sprite bundle. Inside of the sprite bundle, we have to set some fields. First, let's set the transform. We're going to set the transform's X position to be half of the window width. we're going to set the Y position to be half of the window height and leave the Z component at 0 since it doesn't matter since we're making a 2D game. Doing this centers what we're about to spawn in the center of the window. Next, we need to set what texture we want to use. We do this by setting the texture field. We're going to load in our PNG file using the asset server resource. Notice here for the path, it's the path to the file over here in the sprites folder. This asset server.load automatically knows to look inside the assets folder, which holds our two subfolders and our sprites and audio files. For the rest of the fields on the sprite bundle, we're just going to leave them to be the default. Don't forget to add our player component. I hit save to format. This will now spawn in an entity with both the player component and the components provided by the sprite bundle. Let's take a second to look deeper into these two new concepts here. This introduces two new Bevy concepts we haven't seen before: resources and bundles. First, let's talk about using Bevy bundles. Simply put, a bundle is a predefined set of components. If we look at the documentation for Sprite Bundle, we see that it consists of a sprite component, a transform component, a global transform component, a handle, the visibility component, and lastly computed visibility. Notice again, we're only concerned with the transform component and the texture handle component and leave the rest as default. Note, handle is a pointer to the asset we want to use. Note, default is a Rust trait that allows for setting and easily using default values, which many Bevy components implement, and we'll use this extensively. Why use a bundle? Bundles are used as a shorthand to easily and quickly add and remove sets of components to or from an entity. Typically, this is because a certain set of components are all required to be attached to an entity in order to have certain functionality. For example, to have a 2D sprite rendered on screen in our game, we need each of the components provided by the sprite bundle. Caution, we can't and shouldn't use a bundle as a query parameter. We still need to individually list all components we want in our queries. In the future, we'll look at creating our own bundles from our own components, or a mix of both our own components and Bevy provided components. Next, let's talk about Bevy resources. A Bevy resource is simply a unique and globally accessible struct. This is primarily used for data, but can also be used for functionality, like we see with the asset server.load method. Only one resource of each type can exist at any given time. Bevy provides many resources, such as the asset server resource which we just used to load assets from our file system. We can use resources in our systems as system parameters using the res_t and res_mut_t types for parameters. Res_t is read-only and res_mut is mutable. Caution: resources can't and shouldn't be used as query parameters, and are their own parameters in our systems. We'll look at creating our own resources from our own Rust structs soon. Let's get back to our code. Let's go up to our main function and register our spawn player method with the add startup system. We'll do this after we add our default plugins. I'm going to hit save to format. Our main function now looks like this. Before we cargo run and try to see what our spawn player looks like, we're missing one very important thing: a camera. Let's add another system to spawn in a camera. For our arguments, we're going to need commands and another window query. For the body of our function, let's do what we did before and get a reference to our window. Next, we're going to use the commands to spawn in another bundle. This time, we're going to use a camera 2D bundle. For our camera 2D bundle, the only component we're going to set ourselves is going to be the transform. Just like the player, we're going to use the window's width and window height divided by 2 in order to center it, with the bottom left corner being the world origin at 0, 0, 0. We're going to set the rest of the components to be default. Don't forget to add a comma here and a semicolon here. Remember, we also need to register the system in our main function. Our main function now looks like this. Let's run our application now with cargo run. And look at that, we have a ball. That brings us to the end of episode 2. We've covered setting up our first basic game, assets, bundles, resources, 2D rendering, and more examples of using commands with bundles. Still to come is user input, mutable queries, audio, events, UI, and many more examples of concepts we've already seen and new ones we're going to learn. I'm going to try to make shorter videos around the 10-minute mark as opposed to a longer 30-minute video, just to pace things a bit more evenly and keep things a bit more bite-sized. If you have any questions on what we've already covered, please feel free to ask in the comments below, and I welcome any feedback. Thank you guys so much for watching. See you in episode 3.